Hello, Ray, is it audible, right?
Yes, sir.
Yeah, last class what we are doing, Nana? Last class, all, all kids physical properties we did, right? So what are the physical properties we did? So C1 to C4 are gases and C5 to C14 are liquids, and the density is increasing from top to bottom. So means number of carbons are increasing and increases, and boiling point and melting point are increasing with increasing the molecular weight or number of carbons are increasing. So what exactly happens? Surface area increases. When the surface area increases, what exactly happens? So more attractions, more van der Waals force of attractions. That's the reason melting and boiling points increases. Boiling points are inversely proportional to branching, and even number of carbon atoms are having the more melting points because the terminal ends are opposite direction and close packing structure is possible. And solubility, so the compounds, polar compounds are soluble in polar solvents and non-polar compounds are soluble in non-polar solvents. Alkanes are non-polar. Obviously, they are not soluble in water. They are soluble in like CCl4, benzene, etc. So alkanes are less denser than the water, so they are floating on the water. So generally fuels, gases and fuels are petrol, diesel, or of course all are alkanes only. So that's the reason they'll float on the water, right? And chemical properties, we discussed that chlorination is it takes place. The chlorination is 1:2, right? 3.8 is 5. What is this? 1 degree, 2 degree, case of 3 degree for chlorine. If it is bromine, 1:, so 82 is 1600. So means more and more at 3 degree, then less somewhat 2 degree, then very less, because chlorine is, write it down, more reactive, more reactive, less selective. Chlorine is more reactive, less selective, whereas bromine less reactive, more selective. Less reactive, more selective. Write it down. Done? So chlorination and bromination. Bromination is also we can do like that. So if the tertiary carbon is there, for example, the compound is like this. If the bromination is takes place, majority bromine will attach at 3 degree carbon. Write that one. Because 1600 times here is somewhat less. 1:3.8 is to 5 in case of chlorine, whereas in case of bromine, 1:82 is to 1600. Next, put the heading iodination. అదే ఇప్పుడే జాయిన్ అంటుంది మేడం. చూసిన
హలో
చూశాను మేడం. యా డన్. నెక్స్ట్ put the heading iodination. For example, pH3, pH2, pH3 plus I2, right? See, it's a reversible reaction, right? pH3, pH2, I plus HI. HI is a strong reducing agent, and this reaction is endothermic reaction. Endothermic and that is strong reducing agent. Once again, it is coming back, and we will get the alkane. Let's write it down. It's a endothermic reaction, highly endothermic. This is highly endothermic reaction. Highly endothermic reaction, generally exothermic reactions are more favorable, Nana. This is endothermic reaction, means we need to give the heat, as well as the HI is strong reducing agent, so backward reaction takes place. Strong reducing agent and backward reaction takes place. So actually this reaction generally won't take place, but we can do this in presence of oxidizing agents. So oxidizing agents, what they'll do, so they'll reduce the, right, they'll oxidize the HI, Nana. So HI, hello. So HiO3, so HiO3, in presence of HiO3 takes place I2 plus H2O, I2 plus H2O. Three I2, 3 H2O. HNO3 also we can use. We can use the HNO3, NO2 plus H2O, I2. HGO also we can use, Nana. Actually, these products and all not needed. These are not needed actually. So why we are using HiO3, HNO3, HGO? So whatever the I is forming, right? So to prevent the backward reaction, so we will use these oxidizing agents. We have to use. Write it down. ఆన్లైన్లో చూస్తున్నారు ఎవరన్నా? లేదా? So to avoid this oxidizing agents, we have one Finkelstein reaction, right? Finkelstein reaction. Finkelstein reaction. Completed? Winkelstein reaction. So it's a halogen exchange reaction. Halogen exchange reaction. It's a halogen exchange reaction. To prepare iodoalkanes, to prepare iodoalkanes, iodoalkanes from chloro and bromoalkanes. Chloro and bromoalkanes. Chloro and bromoalkanes. RCl or bromine in presence of NaI, acetone, Ri, iodoalkanes plus NaCl is going out. RBr, NaI, Ri plus NaCl, NaBr. So these are the reactions which is coming in the, is a named reaction, is coming in the second year, of course, to prepare iodoalkanes. So directly we can prepare, but directly when we are preparing, we have to use that oxidase, right? So that we need to remove that HI. For that purpose, we are using oxidizing agents like HI, HiO3, HNO3, HGO, like that. So to avoid, so first we need to do chloroalkanes. From chloroalkanes, if we are adding the NaI directly, we are getting the iodoalkanes. The color rasa బాగుంది కదా. Next now, so fluoroalkanes also we can prepare, but directly we can't prepare because fluorination is highly explosive in nature, fluorine. So that's the reason we'll use which reaction? Which reaction? Hello? Schwarz reaction. Schwarz reaction. So either chloro or bromoalkanes, RCl, RBl, Hg, AgF, AgF, or Hg2, F2, or Sb, F3, or CO, F2. So anything we can use, we'll get RF. Chloroalkanes we will get now. Write it down. Done now? Hello? Next put the heading nitration. Nitration. For example, if you are taking the propane, CH3, CH2, CH3, propane, presence of HNO3 at 620 Kelvin, we will get different types nitration mixture of products we will get here. So we'll get 2 nitropropane plus we'll get 1 nitropropane plus nitroethane plus nitromethane. Like mixture of products we will get. Nitration case. Write it down. Then next sulfonation. Sulfonation. So order of reactivity, alkanes 3 degree hydrogen, then 2 degree hydrogen, then 1 degree hydrogen. So we are using, hello. So H2SO4, friends of SO3, fuming sulfuric acid we will use, or H2S2O7 also we can use. H2S2O7. So H2S2O7 we are called as what, Nana? Oleum. Oleum. So here is the hydrogen is there. Methyl ships. Methyl, SO3, H we will get. Write it. Oleum or anything. So 3 degree hydrogen. It is 1 degree hydrogen is there, but the reactivity of 3 degrees substituted by more and more. So SO3H we will get. Sulfonation. Then hello. అవును సార్. అవును అర్జెంటా? చేస్తాం. Next, combustion reaction. Combustion. Combustion, whenever the alkanes on combustion takes place, what exactly happens? We'll get CO2 and H2O and heat is released, right? For example, CH4 plus 2O2 gives rise to CO2 plus H2O, get 2H2O plus heat. Write it down. C2H6 plus O2 gives rise to CO2 plus H2O plus heat. So we can balance the equation. Otherwise, balanced equation we can write like this, no? Cn H2n plus 2 plus 3n plus 1 by 2 O2 gives rise to NCO2 n plus 1 H2O plus heat. Write it down. This is the equation. You know, so anything. So it is what? How many oxygens are there? Obviously, it is NCO2, right? NCO2, 2CO2, 3H2O. So 3N plus 1, 2 plus 1, 2, 6 plus 7 by 2, 7 by 2 O2. 7 by 2 O2, like that. We need to balance the equation. Any organic compound, any alkane. So next, catalytic oxidation. Catalytic oxidation. I told you combustion case, what exactly happens? More number of carbons, more combustion. So catalytic oxidation means controlled oxidation, means particularly, so we are using specific catalyst and specific conditions, we'll get desired product. For example, we'll take methane with oxygen, generally 9:1 ratio at 100 atmosphere pressure, 100 atm pressure, copper, so 470 Kelvin. Particularly, we are maintaining all these, we will get CH3OH, we will get all alcohols. For example, one more reaction is there. Total 4 reactions are there. No? If we take the methane plus O2 MO2O3, molybdenum trioxide will get formaldehyde. Formaldehyde, write it down. For example, if you are using manganese acetate, we will get carboxylic acid. Generally, higher alkanes we will get. No? Next, fourth reaction, 3-degree hydrogen. In NCERT, they given same as it is, so we need to go with the NCERT flow. So 3-degree hydrogen only converting into alcohol. Write it down. Then these 4 reactions we need to remember, very important. Next, put the heading isomerization. What is isomerization? Isomerism takes place, means either chain isomerism or position isomerism. For example, if we can take 1, 2, 3, 4, 5, 6 hexane on heating with AlCl3, anhydrous AlCl3 on heating. So what exactly happens? Isomers. What are the isomers? Compounds which are having the same molecular formula but different in their structure. Chain isomers are like that forming. So write it down. Isomerization. N-hexane, this is. This is 2-methyl pentane. This is 3-methyl pentane. Two-methyl pentane, 3-methyl pentane. if you can take for example AlCl3, so like this we can get isobutane, N-butane, isobutane. Then next nana, aromatization. This is one of the important reaction, from alkanes to convert aromatic compounds means benzene ring, right? For example, if you can take 1 2 3 4 5 6, 1 2 3 4 5 6, actually n-hexane this, I'm just writing like this, in presence of Cr2O3, right? Al2O3 plus Cr2O3 nana. Or we can use V2O5 also, or we can use MO2O3, MO2O3, any of three reagents along with Al2O3. So after directly we'll get here, first cyclization is takes place, afterwards converting into benzene ring. 6-membered, right? If you are taking the 7, what exactly happens? We'll get toluene. If you are taking the 8-membered ring, hmm? We'll get mixture of products, Nana. CH2 ethyl benzene or glycine, ortho dimethyl benzene or para dimethyl benzene also possible. Write it down. Aromatization from, for example, propane is there. Propane on Wurtz reaction will get hexane. Hexane on Al2O3 plus Cr2O3 will get benzene. So benzene to, so prelographs, alkylation, acylation, nitration, anything we can do. Done? Next, pyrolysis or cracking, last reaction. What, Nana? Okay, okay. Then next, Nana. Pyrolysis, cracking, or I could say pyrolysis, or we could say thermal decomposition. So this is cracking or pyrolysis or decomposition. So absence of oxygen, we are just heating, right? For example, in this case, when the thermal pyrolysis takes place, lower alkenes and alkenes we will get. Lower alkanes and alkenes means what? ఒక మనిషిని ఒక బస్తాలు వేసి కిక్ బాక్సింగ్ చేస్తే బ్రేక్ ఎక్కడైతుందిరా? బొక్కలు ఇరుగుతాయి కదా. ఎక్కడ ఇరుగుతాయి బొక్కలు? వేర్ ద బ్రేకింగ్ is takes place, right? One person we are packing in, right? Packing in a bag and we are doing the kickboxing. Where the breaking is takes place? It could be anywhere. That doesn't matter, right? The same here also, when we are taking the higher number of alkanes, for example, here is what 1, 2, 3, 4, 5, 6, 7, 8, for example, an octane is there. Heating, absence of air, if air is there, combustion reaction is takes place. Absence of air, what exactly happens? The product could be anything. Either it could be an hexane, 1, 2, 3, 4, 5, 6, 8, right? Plus ethene, plus hydrogen, like that. Or 1, 2, 3, 4, pentane, plus propane, anything, any possibilities are there. Lower number of alkanes and alkenes. So generally the products are doesn't matter here, because we don't know which products are forming. That's only I'm telling that. So if we are packing a person and if we are doing the kickboxing, right, we don't know where the bones will break, either leg bones or hand bones or neck or backside, whatever it may be, we don't know, like that. Thermal decomposition, cracking, the word is name, we could say the cracking. Alright, crack antam kada. So reaction also crack, we don't know the products, which type of products are forming. Yeah. Done. Next, Nana, fractions of petroleum. So write it down. C1 to C4. Right? Gaseous hydrocarbons. The boiling point range up to, so as a fuel after liquefaction. So gaseous hydrocarbons, right? C5 to C7 petroleum ether. C5 to C7 petroleum ether. Petrol C7 to C9. C7 to C9 means what? Heptane to nonane. So there we are using the petrol. So petrol is a hydrocarbon. Next C9 to C10 benzene related. For dry cleaning, motor fuels we are using now. Kerosene oil C10 to C13. How many of you know kerosene? Kerosene. The kerosene earlier days, the stoves were there, right? Might be in your age there was no kerosene stoves. No. Now kerosene, I think, is it available? It's when I was kid, when I was in your age, I used to kerosene oil. So I was in a room and I was cooking myself with the kerosene oil, and that small stoves were there those days. Kerosene oils. Diesel C13 to C18. So diesel C13 to C18. So that's the reason petrol is somewhat smooth. Diesel is somewhat, diesel engines are somewhat high noise, right? Diesel engines. Actually, these are not needed for the general knowledge purpose, which I'm telling you. Petroleum jellies, petroleum wax. So C18 to C30. Medicinal oil, motor oil, grease, C15 to C18. Grease means, the molecular weight is increasing. They'll become solids right now. I told you C1 to C4 are gases, and C5 to, of course, C14, both in between liquids like petrol, diesel, kerosene oil, they're present in between them. So if you are going the higher wax, since wax, petroleum wax, gels like that, we will get it down. Write it down. Total destruction. Right. So just go through the NCERT, NCERT textbook. So go. See, Nana. So can you see, Nana? The code? So one thing, I'll switch off the lights. Now, can you see, Ra? Hello. Is it visible, the board? Yeah, just what you need to do, you need to go line by line in the NCERT, Nana. So classification, so homogeneous, heterogeneous, right? Alkanes, nomenclature part. Huh? Not clear. Inka bright in the screen brightness etla chestamu. Screen brightness and display. The result. Hmm? Here. What I need to search? Here. No dynamic lighting compatible devices. चलो प्रस्तुताనికి అయితే కానీ చేద్దాం. Right. So just no issues. You can go through the. So you can download the PPT. So you can zoom in actually. Here is. So, now is it okay? Hmm? Right. So even I can do like this. Yes. So just go through the NCERT. Here the nomenclature part. Ethyl. So beautiful examples are there in the NCERT, because NCERT, if you go with the Singh book or something else, we had n number of things, Nana, but NCERT is the standard book, so which we need to follow, right? Preparation of alkanes from alkenes, hydrogen, nickel, platinum and palladium, right? From alkyl halides, zinc and prions of HCl, and Urge reaction from carboxylic acids and coal-based electrolysis. But in coal, only some examples are there, but I already told you how we need to, right? Coal-based electrolysis, substitution reaction, halogenation, and Alcira, it is melting points. I told you what I told. Huh? So even number of alkanes, right? Even number of alkanes here, see, here is 101, ethane 101, propane is odd number, right? It's 85. Where in case of butane is 134, but pentane is 114. No, that's only telling. For example, propane is 85. Propane is the odd number, whereas in case of butane 134, it's increased. Whereas in case of pentane 143, but whereas in case of like that, so it's keep on changing if the branching and everything is coming. So just to, no need to by heart the values, we need to understand the number. So chlorination, I told you HiO3, HNO3, iodination is takes place. So chain initiation, chain propagation, right, and chain termination, combustion reaction, right? So highly exothermic, so 890 kilojoule per mole. Here is controlled oxidation, copper 523 ATM, so MO2O3, manganese acetate, and right, these four reactions are very important. Aromatization, Cr2O3, V2O5 or MO2O3, 773 Kelvin. Reaction with steam, so I think I didn't explain this, so write it down. CH4 plus H2O, steam, will get CO plus 3H2. Just write this one more equation. I didn't explain this. Hello. Hmm. 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 Manganese acetate, right? This one. Yes. H2O, water, steam. This is H2O run. Printing mistakes. Next, pyrolysis, C6, different compounds are coming. Pyrolysis of alkanes, aromatization, conformation, so Sahar's structure, human projection, I already explained this, eclipsed, staggered, right? Structure of double bonds. There is a torsional strain, dihedral angle, I already explained, right? Van der Waals expression, so obviously. Next, actually petroleum and octane, those things are there, I'm not explaining right now. Octane number and calorific value, those things actually not needed right now. So first, whatever the things are present in the NCERT, right? in NCERT. So just go through the NCERT. Okay, na? So I explained there, right, already. Where? So for example, on a CH3, H, 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 H. This is eclipsed one. Okay. Eclipsed means what? Like 1 minute. So can you see, for example, this purple color? Purple color. So purple color. Same side, right? If actually this is carbon, methyl group, hydrogen, hydrogen, like that, imagine. So the front carbon only you can see, right? You can front carbon చూడగలుగుతావు, బ్యాక్ కార్బన్ చూడలేవు కదా. సో ఇక్కడ ఏంటంటే ఇదే స్ట్రక్చర్లో వైట్ కార్బన్ చూస్తున్నాం, బ్యాక్ కార్బన్ ఎల్లో కార్బన్ చూడట్లేదు. సో ఇంకోటి ఏంటంటే కార్బన్ ఇస్ సింగిల్ బాండ్, ఫ్రీ రొటేషన్ ఇస్ పాసిబుల్, రైట్? When the free rotation is possible, when both are the same side, what exactly happens? So because of these groups, repulsions are there. Those repulsions were called as van der Waals repulsions. And because of electron bonds are there. Bonds means what? Two electron repulsions are there. Those we are called as torsional strain. To avoid the torsional strain, so we are just rotating because carbon free rotation is possible. Okay. So if it is totally methyl groups are opposite side direction, what exactly happens? So CH3, CHH. So this is we are called as target, Nana. This is eclipse target. So do one thing in our isomerism videos in our YouTube channel. So just go with 2x speed. So total clearly explained over there. Okay. So just go through that one. If you have any doubt, ask me. Okay, we'll discuss that. Next, Nana. So next we'll do alkenes chapter. Alkenes I'll start tomorrow. Okay. Alkenes I'll explain tomorrow. Fresh topic. Meanwhile, what you need to do is go through the NCERT with line by line. Okay. And any doubts or any reactions. So if you need, sir, I need more explanation in this particular reaction, please let me know. I'll do those reactions. Done? Hello guys.